Hello and welcome to Physical Geology. I am Robert Lopez, your instructor for this class. And today I want to open up one of the lab kits that you've been picking up over the last couple of days. And I have one already kind of opened up here. Some of the things you'll find, and we'll be using for the first week, is you'll find that there's like a drafting tool set. And we won't really use a stencil, but for topographic maps, we'll need the ruler, and there'll be a couple of right angles that we can use, and protractor, really important. That's something we'll need for the first week for topographic maps. And then later on, when we do earthquakes, you'll need a drawing compass. So here's a little drawing compass because we draw circles. And this, you'll see there's a little eraser and some other things in here, but that's a tool we'll need for a couple of different labs. And then you'll find that there's some labware. There's a couple of these 100 milliliter beakers. I think on the list, materials list, I said there were 3. There's only 2. So there's 2 of those. I have a clear plastic cup. Initially, I was going to put a can of soda in the lab kits, but I just didn't get around to get the soda. So for volcanoes, you're supposed to put a little bit of carbonated drink in here and see what happens with the bubbles. So if you have soda for the volcanoes lab, you can use the clear plastic cup here for that. And then there's also a graduated cylinder, 100 milliliters. So you'll definitely need this for minerals and a couple other different labs. And then there's a thermometer that we'll be using as well. Now, for the igneous rocks lab, you'll need these 2 styrofoam cups, and you'll read the instructions for that. And then you'll also have the 250 milliliter beaker as well for that. And then for topographic maps, we have the topo map, right? So this is for the first lab that you'll be using. So some of you will have the Bray quadrangle, others will have the Ennis quadrangle. But you'll see there's questions related to the 2 different maps, right? So that's the topo map. Then there's a pocket scale, right? So the key thing is make sure you open this up. I think all these are pretty much brand new. You'll probably have to add the battery to them. Make sure you figure out how these work. They're pretty straightforward, but you'll need these for weighing the minerals and doing some kind of density calculations, right? So that's a mass balance there. And then now for the different rocks that are here, right? So we have rocks and minerals, 2 different kits here. And then for the minerals kit, obviously in the lab, you'll find I have a bunch of lab videos where I describe minerals, I do some tests on the minerals, but these you're going to identify. So your job is to identify these based on the different steps and activities we do during the lab. And one section of the lab is going to require you to do the density, and you can see that density is going to be this mass over the volume over here. And so the mass, obviously, you're going to weigh the mineral sample on your mass balance, right, to get the mass. And then to get the volume, you're going to put some amount of water in here, carefully read the meniscus, right, so I talk about that in the lab, where that value is, and then record that. And then you want to make sure the mineral fits inside the graduated cylinder, because then you'll see a volume displacement, right? And that's going to be your volume, and then you can finish that calculation, right? So these are the minerals, right? So you're going to use those for the minerals lab. And then for the rocks, we have all 3 in here. Igneous, sedimentary, and metamorphic rocks are in this rock kit. And there's different numbers on these, and in the lab, I'm going to tell you which are going to be the igneous, which are the metamorphic, and which are the sedimentary, right? So you'll be just focusing on those for those particular labs, right? So there's the different rocks right there. We got the minerals. And then other than that, there's a bunch of different baggies, right? So here's the minerals baggie. And the minerals baggie is going to have a variety of different things. And some of these tools you'll use later on for other labs. Here is the knife. Knife is important because it's a sort of like a litmus test for minerals that separates minerals into hard minerals versus soft minerals. Hardness of a knife is 5.5, which is the same for the glass plate. But the way we use a knife, if you can scratch the mineral with a knife, then it's a soft mineral. If you cannot, it's a hard mineral. But sometimes when you're scratching minerals, you'll see that there's a little mark on there, and you think you scratched it, but in reality, it could be the metal being scraped off on the hard mineral. So if you get something like that, like quartz is a good example. Quartz is hardness 7, which is harder than 5.5, which is this knife. The glass plate is also 5.5, but when you use the glass plate, make sure you, obviously you take it out of the little bag here, but you put it flat on the countertop, and you want to scratch a mineral across the surface of the glass plate here. And if it leaves a scratch, then you know your mineral is harder than 5.5, which is the hardness of these two items right here. We also have a porcelain plate, which is called a streak plate. And so this is, we want to know what the powdered color, or at least a powdered form of the mineral, what color it is. And so again, this you want to put flat on the countertop and powder your mineral, scratch your mineral across the surface. They'll leave some characteristic color. And you want to record the color of that streak. And sometimes, especially if there's sulfur, you'll smell the rotten eggs, right? Or the kind of the hydrogen sulfide on there. There's also a little wire nail, which is about hardness 4, and that may help you in the mineral hardness you'll do, the little tests you'll be doing. We have a little acid bottle. It's 10%. It's relatively weak acid. This acid bottle, there's only one mineral we use it on, and we really use it on the calcium carbonate, because that's the one that's going to react in acid. Or limestone, sedimentary rock that's composed of In fact, limestone, by definition, is a rock composed of calcite, the mineral calcite. So if it gets on your hands, don't worry about it. Just wash it off. It's not going to hurt you. But if it gets on your clothes, it could put a hole in your pants, right? So try to have paper towels around and make sure as soon as you put a drop on your mineral, you see if there's any reaction. And if there is or isn't, you want to wipe off any excess hydrochloric acid, right? So again, use this sparingly and really only on limestones and if you think you have calcite here. And then there's a couple of little eye loops. Yeah, you'll use these to kind of help you for magnification. You'll see that, in fact, I guess I'll give you a link to this, but there is an app. There's an app for everything, right? It's called Loupe, L-O-U-P-E, and this Loupe app is pretty cool in that it allows you to magnify the different samples, right? So I recommend this, and it'll help you, especially when we're looking at sand, because some of the labs, especially the sedimentary rocks lab, we're going to be looking at sand, and this little eye loop app will help you zoom in and really try to identify the minerals that are in that lab. And so after that, you'll see that there are little baggies. We talked about the minerals already, but in fact, let's just talk about the sedimentary rocks lab here. 3 sand samples, and there's 2 little rocks in here for kind of, you crash them together and you make sediment. We have an earthquakes lab. We have cornstarch plus a couple of marbles in there, so you'll see that we're going to make some paste out of that to simulate liquefaction. This is a metamorphic rock, so here there's some crushed aspirin, some baking soda, some white crystal, and so you're going to be dissolving this white crystal in this test tube here with a little stopper, using both cold water and warm water, and then you'll kind of compare the rates of dissolution to talk about metamorphic reactions. Here we have a little groundwater baggie, and so we have round gravel versus angular gravel. You'll be using these smaller beakers to kind of see what's going on with the porosity and of these two materials there. And then we also have a weathering lab. The weathering lab, there's 2 parts of it. This is the second part, which involves looking at the angle of repose, which you'll need your protractor to measure think about sand dunes. Sand dunes never really get steeper than about 33 degrees. So you're going to try to simulate that with the sand. And also we'll compare it to this kind of fine gravel as well. And then for igneous rocks, here we have this salal powder, and it melts at a relatively low melting point. So you're going to place some of that salal powder into this beaker, or sorry, not the beaker, this test tube, and then you're going to have your 250 ml beaker here with hot water. And I think the water needs to be about 80 degrees. So you use your thermometer to make sure the water is about 80 degrees. You can either warm it up in the microwave, or I'd prefer if you use a kettle, like an electric kettle that you make tea with. Pour it in there, make sure the water is between 80 and 90 degrees, and then you'll have your powder in the test tube. Then you'll put your test tube into the hot water bath, and you'll wait about 5 minutes, and it'll completely melt. And once it melts, you're going to create two different environments with your styrofoam cups, and you'll pour them in there, and you'll see the rate of crystallization, how quickly or slowly crystals form. So this is for the igneous rocks, right? So there's only one experiment we'll be doing there. And the last part of the lab is the fluvial part. And this fluvial part, fluvial refers to streams or channelized water. And in this lab, there will be 3 different maps of rivers: the Arkansas River, the Missouri River, and the Mississippi River. And you'll see that the rivers are gonna, rivers really don't travel straight paths, right? They kind of do this curving or meandering path. And we want to figure out the distance that the river travels along those meanders, right? Those bends in the river. And to do that, you really can't do it with a straight edge, a ruler. We need to use a string. So in this envelope here, there should be a little string, right? And the string is used to place on the map along the curves of the river. So you'll do all the bends of the river, then you can straighten it out, and you'll see that each map has a little bar scale at the bottom down here. There's a little bar scale at the corner down here, and you can measure how many miles the river has traveled. That curvy path, you can stretch it out into a straight path, right? So that's how we're going to use a string. So that would be the fluvial part, and that's going to be in this envelope here. All right, well, that's it for now, and I'll see you guys online.